Let us look at one more question here. It says from the given fx graph, find the work done by f from x is equal to 0 to x is equal to 5, x is equal to 5 to 9 and x is equal to 0 to 10. So, look at the graph here and see that for the first 5 meters of distance, this distance, the force is a constant. And anyway, we know that the work done by a force can be calculated now from the area under the force displacement graph. So, in this particular case, in the first case, this will be the area that we will be looking for, which is nothing but the area of this rectangle. Yes. So, the first part, for the first part, the work done can easily be calculated as work is equal to area of this rectangle that we are getting, which is equal to 10 times 5, yeah, which is 50 joules. Then for the second part, call this W1. For the second part, W2, let us say from x is equal to 5 to x is equal to 9 for this interval. Now see that for this interval, the force varies from f is equal to plus 10 to f is equal to minus 10. In between at x is equal to 7, the force becomes 0 also. So, when we again use the same method of finding out the area under the graph, we see that we first have to find out the area of this triangle here and take it as a positive area, and then find out the area of this triangle and take it as a negative area, and then add the two with the minus sign. Yes. So, can we say the second work done will be half into the base length, which in this case for the first triangle will be 7 minus 5, that's 2, into the height, which is 10 newtons, so 10. This is the first area, the positive area. Subtracted from this, the second area, which by the way comes out to have the same magnitude, half into the base, which is 9 minus 7, 2, times the height, 10. So, it comes out to be the same, 10 minus 10, both the areas are of the same magnitude, and hence the work done comes out to be 0 for the time interval 5 to 9 meters. The third part, where we are supposed to find out the total work done from x is equal to 0 to 10. See that the only extra remaining area now is from x is equal to 9 to x is equal to 10, which corresponds to this area of the triangle, the smaller triangle, and the area would be negative as we have the area below the displacement line. And if I call it W3, which is from x is equal to 9 to 10, this will simply be the area of the smallest triangle that we have as half into base length here is 10 minus 9, that is 1, times the height, which is minus 10 if I have to take it along with the sign, and this gives us an area of 5 joules with a minus sign. Minus sign essentially is telling us that the area is negative because it is below the displacement line. So, now what we need to do is the total work done that they are asking for in the part C, from x is equal to 0 to x is equal to 10 will be nothing but the work done in all these three sections, W1, W2 and W3. So, we can add all of them. W1 is 50 joules, added to that for W2 which is 0 joules, plus the work done in the third part, x is equal to 9 to 10 is minus 5 joules. Solve it to get 45 joules as your final answer.